Welcome to this short lesson on Introduction to Infrastructure as Code IAC using Terraform. In this lesson, we explored the core concepts of Infrastructure as Code, IAC. We explored Terraform, an essential tool for automating and managing infrastructure and configurations. We will look at Terraform's modules and state management. Let's get started. Infrastructure as Code, IAC is the process of managing and provisioning infrastructure using machine-readable configuration files, rather than through manual processes. To automate the setup, scaling, and management of servers, databases, networks, and other resources. Infrastructure as Code, IAC, is a pillar of modern DevOps practices. By automating infrastructure and software configurations, you can enhance consistency, reduce human error, and increase the speed of delivery. Tools like Terraform, CloudFormation, and others are used to define infrastructure resources. For example, VPCs, EC2 instances, and load balancers. Let us look at Terraform. What is Terraform? Terraform is an open-source tool created by HashiCorp for automating the provisioning of infrastructure as code. It allows you to manage infrastructure in multiple cloud providers. For example, AWS, Azure, Google Cloud, as well as on-prem environments. Writing Terraform modules. Terraform modules are containers for multiple resources that work together. They are reusable components that help break down large Terraform configurations into smaller, manageable units. Benefits of using modules. 1. Reusability. Once written, a module can be reused across different configurations. 2. Maintainability. Changes in the module can be applied across all configurations that use it. 3. Separation of concerns. Modules allow you to separate different parts of your infrastructure into logical units. Best practices for writing Terraform modules. 1. Single Responsibility Principle, SRP. A module should have one specific responsibility. For example, an EC2 instance module should handle the provisioning of EC2 instances, but not handle VPC setup. 2. Directory structure. Organize your modules in a directory structure that makes sense. Typically, you might have modules, VPC module, security group module, and instance module, as displayed on the screen. 3. Input variables. These are values that are passed into the module to configure it. You should declare variables in the module, making it flexible and reusable. 4. Output variables. These are values that the module returns to the parent configuration. For example, you might want to return the instance's public IP. 5. Avoid hardcoding values. Don't hardcode resource values. Instead, use variables to provide flexibility, so that modules can be reused across different environments, such as development environment, test environment, and production environment. 6. Version control, such as module versioning. It's a good practice to maintain different versions of modules, especially when making backward incompatible changes. You can version your modules and pin the version in the configuration files. 7. Use local values for complex expressions. If you need to perform complex expressions in your Terraform files, use locals to make it more readable and easier to maintain. State management and drift detection in Terraform. Terraform uses a state file, terraform.state, to track the resources it manages. The state file records metadata about each resource, including IDs and dependencies. There are two types of state file. 1. Local state. is stored on your local machine. 2. Remote state is stored in cloud storage or a system like S3, providing better collaboration and security. Drift detection. What is drift? Drift occurs when the actual state of infrastructure differs from the desired state defined in your Terraform configuration files. This often happens when changes are made manually to resources outside of Terraform. Detecting drift. Use Terraform plan to compare the actual state to the desired configuration. This helps you identify any drift in the infrastructure. Preventing drift. 1. Regularly run Terraform plan. Frequently running Terraform plan helps detect drift early and brings your infrastructure back into alignment with the code. 2. Use version control for configuration files. Use Git to store your Terraform configuration files. This provides version tracking and ensures everyone is using the same configuration. Example of using remote state with S3. For recap, in this lesson, we thoroughly explored the core concepts of infrastructure as code, IAC. And we explored Terraform's modules and state management. In conclusion, Terraform is a powerful IAC tool for provisioning infrastructure across multiple providers. Writing reusable modules and tracking state are core concepts of managing infrastructure with Terraform. To help you reinforce what you've learned and explore more advanced lessons, please click the link in the description to access this lesson on Motiva Logic Academy Learning Management System, where you'll find a quiz for every lesson, hands-on lab and projects to test and strengthen your understanding. While you're there, explore the full catalog of advanced hands-on courses and downloadable resources designed to help you move from theory to real-world expertise faster. Be sure to like, subscribe, share and visit the link in the description. Don't forget to turn on notifications so you don't miss the future lessons. Thank you for watching.